Hello Rob, welcome to another kwyll video. This one's going to be a little bit different. I have got a lot of things that I want to discuss about what's been changing in kwyll, but I need a little bit more time to put that together. But I wanted to put something out. So some of you who are following may know that I did a small, very quick game which I released on itch.io. I'll put the link somewhere in the description. A Christmassy game. Just really wanted to put something out to sort of get some interest and show a little bit about what kwyll can currently do. So I did that, and what I want to do on this video is just quickly go over how the game works, or a making of, effectively. So a little bit into some of the tricks that I use, some of the tips that might be useful in your own games. Some of the problems I encountered. I'll go into the code, the logic, which is obviously the core of how any game in kwyll works. So I'll go into some of that in detail, and hopefully you can pick out some useful bits from it. It won't be a tutorial by any stretch. It's just more this is the game as it is, and this is how it works, and maybe a little bit about why I did things a certain way. So I'll go over each different aspect of the game individually. I'll try and make sure they're in the right order, make sure that things make sense. I'll start by looking at the objects in the game that make the core of the game, starting with the Santa, the main character, the player, and we'll move on from there. So let's have a look at the main character, the Santa character. And start with the sprites. So let's switch to our editor view. Now the sprites for Santa, I decided on a size of 24 high by 16 wide. So you can see this by three cells. Just allowed me to fit something in of a reasonable size. I've defined a number of different sprites here. So I've got a basic facing right, facing left, just mirrors of one another using the mirror tool. A couple of frames of running animation, just to keep it simple, and also for left. And I've got a couple of frames for climbing up and down, just from the back. Now there's these other ones here which are basically copies and then shifts of the facing right standing position, and these are for when Santa goes down a chimney. And the reason I did that with sprites rather than moving an object is there's currently no way in kwyll of having an object draw behind any cells, any tiles. So I couldn't use that mechanism. I'm looking into ways of making that possible. The sprite library that I use in kwyll does have a facility for making tiles always draw on top of objects, so I'll look at maybe exposing that in a future version of kwyll. But for now, I just defined a few frames of an animation of him just going down the chimney, just to make it fairly simple. So if we go to the object, you can see I've defined all these different animations here. So we've got the two stationary left and right. We've got the run animation left and right with 4 frames cycling between the two run frames and with the still frame in the middle, which gives a reasonable running animation. We've got animation 4 is for the going down the chimney, 5 is for climbing up and down ladders, and then 6 and 7 are just still single frames for the left and right running animation, but they're used for jumping. So when you jump, you don't run in midair, you just stop, your legs and arms moving, and he just keeps his that position as if he's jumped. So those are the animations we've done. Fairly simple. You'll see they're all masked so that the Santa character should interact well with the background in terms of pixels. And then we have to go and look at the logic. Now this is where the vast majority of the logic for the entire game is on the Santa character. There's bits and pieces in other areas, like in the global logic, in the game logic, and on other objects and on the screens and rooms, but the vast majority is on Santa. So it can look a little bit unnerving at first, the amount of logic, but I'll go through each piece in turn. So this is the logic. You can see there's a fair bit there, but and there's more over here. But I'll go through each one, and you'll see that I've broken it up into little chunks. So each chunk effectively is a flow initiated by a trigger, and I'll go through the reasoning behind each one. You'll see we've got a whole host of variables up here. These are for storing things like the state of the character at the time, whether he's running, jumping, landed, on a ladder, climbing, what velocity, and so on are all stored in here, as well as things like whether the character is currently standing on a chimney or in the vicinity of a chimney, in the vicinity of a present to be collected, and so on. But all of these will become clear as I go through and explain what each of these flows does. Now this whole section over here, which I've separated away from the rest, is all about the character movement, and it's broken down into pieces to make it relatively simple to understand, rather than having one big long flow that does lots of branching. So one thing to remember for kwyll flows is if you have multiple triggers of the same type, they'll all run. So for example, in this case we've got multiple always, they'll all run every frame. Always is unique in that it allows you to define the order with this order parameter. All the others will just run in an arbitrary order. So things like object hit and tile touched and so on will just, if you have multiple triggers of those, they'll all run, but they'll run in an arbitrary order. You have no control over that. But having the control over the order in the always is really important in this case, because I want to do things in a certain order. Now what I'm doing is I'm capturing in various flows up here effectively a state, and that state consists of an x and y velocity, which is then used to move the object, flags like can jump, going down, etc., and on ladder, and then a direction and an anim. So the direction is which horizontal direction you're facing, left or right, and that's a latch, which I'll explain in a moment. And then anim is further down here we determine which animation to play based on various different things going on, and then at the very last thing we set the animation so that the sprite is playing the correct animation. So starting at the top, order 0, the first thing it does is check the left, right and up buttons, and basically sets the x and y velocity based on whether those buttons are pressed, whether the player can jump. Now the can jump flag is set effectively when you land on something. So when you land on a platform or on the ground, I'll show you where that happens in a moment, then it sets the flag to say it's possible to jump now. So when you're in mid-air, you can't jump. So first of all, it checks to see if the very first thing it does is basically set the x velocity, which is just left and right. I'll set it to -2 and 2, so it's 2 pixels per frame, which is a comfortable speed. And then the next thing it does is check to see if the up button is pressed and if it can jump. So if the up button is pressed and the can jump flag is non-zero, then it'll go up here and it'll set the y velocity to the jump strength. Now the jump strength is a variable here which can be set on the instance. So the instance of Santa here is a map level object, and if we double click on here you can see we've got these exposed variables, and jump strength I've set to -8 because -8 is up in the vertical direction, vertical axis. So then it'll set the y velocity to the jump strength, which you can tweak, and then play a jump sound. If either the jump button isn't pressed or you can't jump at the moment, which will be a false out of this logic flow, it sets the y velocity, it decreases the y velocity effect, or it applies gravity, so it adds 1 to the y velocity. So if you've been jumping and you're at 8, it will slowly reduce that down towards 0, and then go beyond 0 for falling. So and it clamps that to the jump strength up, so it can't go up any faster than the jump strength, and down 6, which is just 6 pixels per second effectively, or 6 pixels per frame effectively going down, which is a reasonable falling speed. You can tweak this value if you want it to fall faster or slower, and then sets the Y velocity to that. So this is basically reading the input, checking things are valid, and setting the X and Y velocity as an initial based on the player's input. And then following that, we've got another always, and this is order 1, so it always comes after this. So these X and Y variables are set to, velocity variables are set to whatever that logic determined, and then it checks to see if we're on a ladder. Again, I'll show you how the ladder flag is set at the moment, but it's another flag here which is set to 1 if the character is on a ladder, and if it's not equal to 0, it is on a ladder. Then it sets the Y velocity to the player's input on up and down. And again, I'll set them to -2 and 2, so you move up and down 2 pixels per frame, and just sets the Y velocity to that. So this will then overrule anything that's going on in here. So if you're not jumping, for example, and gravity is being applied here, then you'll get a certain Y velocity there based on the gravity, but then this will come over and say, actually, you're on a ladder, so ignore that, set the Y velocity to what the player is moving. And if the player isn't moving, isn't using the up and down buttons, this answer would be 0, so it sets the Y velocity to 0, meaning it will stay stationary on the ladder. Okay, on to the next step. This is order 2, so this will come after that one. Now this one is checking to. This one is actually doing the movement of the player now. So we've already worked out the X and Y velocity based on input and whether you're on a ladder and climbing or not, and it will just basically take those X and Y velocities, add them to the current position, and move the object to that new position. Now what it's doing in here is it's setting can jump back to 0, and that's important because we want to be able to check further down here whether we can jump or not. So next frame comes round, it will set it to 0 here, and then further down in another flow down here, not an always flow here, it will set it to 1 if we've landed. So basically what happens is, if we get back to our move, this move will try and move the object to the new position. If doing so would make it collide with a platform or the floor or anything moving down, then this collided trigger would hit and it will set it to 1. So we're just setting it to 0 there, just so that it starts out as 0. If you hit something, then it sets it to 1, which means you've landed and you can jump. If it doesn't hit something, that means you're in mid-air, which means this can jump variable stays at 0, which means next frame you can't jump. Okay, hopefully that's clear. Moving on to the next one. There are a few, I did warn you there are a few here. Most of them are fairly simple though. So this one's really simple. So this is basically, this is the latch I mentioned on the DIR value, the direction value. Now what we want to do is set the direction only if you're moving, if the player is being moved by input controls. If the player isn't being moved, i.e. if the character isn't being moved, i.e. the player is not using the left and right controls at all, then we want it to stay in the, we want the direction variable to retain the value that it was before. I don't want to set it to something fixed. So this is what's happening here, is after doing all of that, it checks the velocity. If it's not equal to 0, then it will set the direction value to that velocity, which will be -2 or 2. If it is 0, it'll leave it alone, which will leave it at where it was before. So that way, when you stop running or you stop jumping, and it goes to the idle animation, the still animation, it'll be facing in the right direction until you change direction. So that's just a simple latch. Useful trick. So moving on to 6. So this one is setting up the basic animation for running and running and not moving. So this one checks first of all if the X velocity is 0. If it's not 0, then we set it to either 2 or 1, depending on whether the direction is more than or less than 0. So if we look at 2 and 1 and we go to here, 2 and 1 are the running. So basically, if we've got this far, the X velocity is non-zero, so we're running or we're moving, and therefore we use one of those animations. If, however, the X velocity is 0, we're not moving at all, the player isn't touching any of the keys, then it does the same thing, gets the direction if it's less than or greater than 0, and sets it to 3 and 0, which would be left, right and left, 3 and 0. So that's just basically setting up the animation based on the current X velocity, and it sets this anim variable, which is this one here. So it's not actually changing the animation at this point, it's just saying, based on my current knowledge of the velocity and the direction, this is the anim I think it should be, the animation that should be used at the moment. And then we have another one that follows on, order 7. This if is checking to see, can you jump? You can't jump and you're not on a ladder. And if you can't jump and you're not on a ladder, then it sets the animation to 7 and 6. So basically, if you're in mid-air and not on a ladder, you've been jumping or you're falling, then it sets it to 7 and 6, which is these ones here, the jump or fall animations, which is just a single frame of jump. I can show you this very quickly so you can see what it looks like. So as you can see, when you jump, he holds that single frame of animation. In fact, if we slow down the simulator a bit, you'll see it a little bit better. Slow this down a bit half speed. So there you go. So when he's jumping, he holds that single frame. So that's the basic animations for left and right and jumping or falling. So moving on to the next one. So this is another animation one. This is basically if you're on a ladder and the Y velocity is not equal to 0, so if you're on a ladder and moving up and down the ladder, then we set the animation to 5, which is a climbing animation. And then finally down here we've got all the information we need to determine the animation. These ones have overridden each other, so the most important one is if you're on a ladder at the end, and it starts off with just left and right. It just does one final check to see if the going down flag is set, which is this variable here, and if that going down flag variable is non-zero, it'll do nothing, so there's nothing here. So if you're not going down, then it will set the animation to the one that's been decided by all of these flows up here. So finally setting the animation to be left or right or jump or climb. And then, as I showed before, this is just basically when Santa moves, if it collides with any tiles, if that tile is on side 2, which if we hover over here we should see is down, so it's collided in a downward direction, then it sets can jump to 1, which means you've landed and you can jump next time round. So that's basically all of the movement. It looks fairly complicated, but as I say, it's broken down into small chunks to make it fairly easy to follow. So we'll stop there for a moment, and I'll move on to this bit next. Okay, so with all the player movement out of the way, we now need to work out how Santa, the player, the character, interacts with other parts of the game to make the gameplay work. So there's a couple of things we need to do. First of all is the chimneys. So the gameplay, for anyone who's played it, you have to collect a present and take it to the right house and go down the chimney and deliver it to the tree. So the first thing you need to do is work out whether you're on a chimney or not when certain things happen. So we keep that flag set using the on chimney variable, this one here. So when an object is hit, if it's a type chimney check, which is another object type here, then it sets the variable on chimney to that object reference, so it stores the actual chimney object in that variable, and then sends a message to the object, which I'll go into Y in a moment, message 1. And then when you leave, if it's a chimney check object that you're no longer touching, then it sets the chimney check to 0. Now we can see this in action. If we go back to the preview again, and if we look at on chimney, so keep an eye on that variable. Now I know there's a chimney up here obviously, so if I go over here and I jump up, you can see this now becomes the object reference to the object that we're on, and as soon as I leave that object, it becomes 0 again. So chimney check is either the object reference or nothing, which we can use later. So those are happening on object hit, so they're triggered when we hit one of the objects. And if we just have a quick look at the room, just so I can show you what I mean. So this is the chimney check object here. You can see it's just it has no visual representation, it's just a square that detects when the Santa hits it. So back to here. So on this, in this section now we've got another always flow. This one happens at order 0. It doesn't matter when it happens because it's not interacting with all of the player movement stuff. This is entirely separate. What this does is check to see, first of all, are we on a chimney, i.e. is the on chimney variable something other than 0, and is the player pushing the down button? And if they are, then we have to go through this dance here to check whether the present we're holding, if we're holding a present, matches the present that the chimney or this particular house needs. And I'll go into how those variables are set up. They're global variables. I'll go into how those are set up in a moment. Basically, if these two match, then it starts the going down animation by setting the variable going down, which you remember we were checking earlier, to 1. It starts out at 0. Once it's set to 1, it will go through a sequence doing the animation and all the movement and everything that you'd normally do. If I just quickly go back over to here, you'll see, where was it? Going down on ladder. It's the animation. So basically, if going down is non-zero, then it won't change the animation, which means it's going to continue playing the going down animation. So getting back to what we were. So it sets that to 1, which starts the animation going. If we either haven't got a present, we're not holding a present at the moment, or the present we're holding doesn't match what the chimney requires or the house requires, then it'll follow this flow, which basically messages the chimney, and I'll go into what that does in a moment, and just plays an alarm sound to say you don't have the right present. So to keep things flowing, I will have a quick look at this because it's fairly simple. So it's message 0 on the chimney, which is the chimney check. It'll basically get the present variable, which is something we can set. It's an index of the presents 0, 1, 2, 3, 4 or 5, depending on which present this chimney needs, and send a message to the default screen, which I won't go into now because it's a little bit more involved, but basically prints the message up on the screen saying you need this present for this house, and prevents you going down the chimney. So if we go back to Santa now, so we know what that does. And then down here, the last bit of this particular section is processing the going down. So this is an always, which will happen every frame. If going down is not 0, i.e. it has been started, the animation has been started up here, then it'll increase it by 1, and if it's greater than or equal to 28, which I've worked out is long enough for the animation to complete, enough frames going through here for the animation to complete, then it will set it back to 0. The animation, the falling through the climbing down the chimney animation has completed, and doesn't need to be run anymore. And then it will set this variable, last location, to the current location. Now the reason for that is when you go down the chimney, it takes you to the interior location, and when you leave the interior location, you need to come back to the same. If we go to the map, I'll show you what I mean. So we've got the interior location separate over here, but when you go down this chimney and then you leave through the door, you're going to want to come back to this same location. So it stores that so that we can use that later, and then transports the player to marker 0 in the interior location. And I'll just quickly show what the interior location is. So marker 0 is here, which means he'll appear here and just drop down into the level. So that's the chimneys. The next section is what happens when you hit something that damages you. Now this is handled through this whole flow here. This section of the flow is what happens when you get damaged. So it sets the variable killed, it sets the player Santa to checks layers so that it can't interact with anything anymore, and turns active off so that all logic now stops on the player because he's dead. And then messages the global logic ID 0, which I'll go into what it does in a moment, and plays a sound. Over this side you've got two ways that you can actually be killed. The first one is when you get an object hit trigger come in of type baddie. That will run this killed flow, killed logic. And the second one is if you touch a tile and it's of tile type 1, it's set and killed is 0, so if it's already 0, so it won't do it multiple times. Editing Paul here. I just wanted to clarify something about this extra check on the killed variable here that I didn't get first time through. The reason that I check when you're doing a touch tile reaction that killed is 0 is because if you touch multiple tiles, this trigger will be triggered for each one, and you don't want to go through this process, especially this part of the process, which you'll find out in a minute, for each tile that you hit. So if we look at the room very quickly, I'll show you what I mean. If we go to room 2, you can see we've got these tiles down here, a few of them. If I drag the Santa on, if he's here for example, he will be touching both of those, and both of those will trigger the logic, which would mean he'd die twice. So I just wanted to clarify that and explain why that's there and not here. Then it'll do the kill logic and kill the player. And if we quickly look at the rooms and the tiles, we can see that tile type 1 here, so the green is the type. These are all 0, they don't have a type, but this one here is type 1. So if I look at room 2, I think we've got a few of these down here. So if you hit one of those tiles, that will also trigger the killed logic. There's no energy or anything, it's just as soon as you hit something that's bad, you lose a life. Very simple. I think I might actually just quickly show you what the global logic does, just so that we can keep all this in mind so we don't sort of get lost. So if we have a quick look at the game logic, this is sending a message ID 0, and if we look here, we've got ID 0 here, which is I've marked as killed. Just basically reduces the lives by 1, messages the screen to say that a life has been lost, and the screen will update the number of lives, and then starts a timer for respawn. This is a global variable respawn timer. Connected to that, we've got this respawn timer logic down here. So this is running every frame. If the respawn timer is not 0, then is greater than 0, then it will decrease it until it reaches 0. As soon as it reaches 0, it checks to see if Santa has any more lives left. If not, it switches to the menu screen. The game's over. If you have lives left, then it transports you to it transports Santa to marker 0 in the current location. And if we go to the rooms, you can see each of the rooms has a respawn point at 0. That one will be there, which we. Each one of those has a respawn point where it comes back, and then plays a sound. Oh, sorry, we were looking at global logic, weren't we? So that's basically what happens when you die. The global logic takes care of running a timer and respawning you if necessary, if you can. So that's dying. We're getting to the end of this one. This one you'll notice is order 100, so this happens right at the very end. This is just safety checking, so basically it's setting kill to 0 and on ladder to 0, so that next frame round all of the logic that checks to see whether you're on the ladder and whether you've been killed starts from a clean slate. So this is at the very end, after all the logic that cares about whether these variables are set has been done. It gets reset to 0 so that next frame round they all start fresh. These two are touch tile types. So this is where I mentioned earlier how the on ladder variable gets set. So if we look at the tiles here, tile type 2 is the 2 ladder tiles. So 2 is in green. So if you've touched tile type 2, it sets on ladder to 1, so that the rest of the logic can determine that you're on the ladder. And this one here is if it's type 3. So if we go back to the rooms and look at tile type 3, it's this white tile, and you'll see it here used on the door. So this is just an easy way of determining whether you've hit the door in the interior room. And that basically just transports you back to the last location. So it waits for no key to be pressed, so that the input's all clean when you get transported to the new, back to the above ground or the exterior location. Gets the last location, which if you remember we stored when you go down the chimney. Where were we? There you go, last location is set to the current location there before going inside the house. So this will then transport you back to marker 1 in the last location, and if we look at each location you'll see marker 1 is by the chimney, so that you come back out at the chimney in each location. So that's those, and then the last two down here we've got object hit and object left for the tree. So the tree is defined as a, if we look, so there's a if we look at sprites, no. Object types tree has no sprites, but it uses the sprite sheet main, so its size is 24 high by 16 wide, and so we basically place one of these over the tree, which is actually tiles drawn using tiles, and then if we look at the Santa logic again, as it enters the tree it sets at tree to 1 and sets at tree to 0 when it leaves. So we can determine when dropping a present, which you'll see in a moment, whether you're at the tree or not. So this is just a state flag. So we're finally getting to the last bit of it now. This is one that I have actually pushed into a frame with some documentation in. I'll try and do some more for the others when I get a chance. But this is all about handling presents. So we've got two in this section. We've got two object hit and object left pairing, similar to the tree. This one is whether the object is a present or not. So again, much like the chimney detection logic, it will detect when you hit one of these object types and store the reference to that object in the on present, and I'll show you that working again in the simulator. So if we're watching now on present, So if I jump up to the teddy bear, you see as soon as we touch the teddy bear, you're on the present. You haven't picked it up, but you're touching that present. So that's how it tracks that. And then when you leave, it sets it to 0. And then we have an always flow on here, which checks to see whether the fire button's been pressed. And if it has, so if we go through here, if the fire button is pressed, first of all checks to see if we've got a present. And this is a global variable, as I mentioned. If we go to the game logic, you can see needs present and got present are variables up here. So if we have got a present, i.e. it's greater than 0, no, let's see, let me just remind myself what was happening there. So the got present is not an object, it's an index. And it's an index of the present that you need 0, 1, 2, 3, 4 or 5 of the different presents. If you haven't got a present at the moment, it's -1. So it defaults to -1. So if it's greater than, then it sets the variable got present to -1 because we're now dropping the present. Messages the screen with ID2, which tells the screen to print up the present that you're currently holding and sets it to -1, which the screen logic will recognize as not holding any present. And then it will move the present that you were. First of all, it will check to see if you're at the tree. So this is this defines what happens when you drop a present at the tree versus anywhere else in the game. So if you're at the tree, the first thing it does is equals 0. So at tree is equal to 0. If excuse me, if it's true, that means you're not at the tree, because if at tree is 0, then the true path will be followed. So this is now what's happening if you're not at the tree. It transports the object, which is the present object that you're holding, to your current position, so X and Y position. We add 8 to the Y position because the presents are 16 by 16 and the Santa is 24 high, so it just drops the present down by 8 pixels so that it's at the same ground level as the Santa, and then moves it to that position, and then it sets the flags visible and the layers, the collision layers, back on again, so that you can now interact with that present again because it's been dropped back into the scene. And then it sets the present object, which is the one that you were holding, back to 0, and plays a sound to say that you dropped the present. Now this will follow if you're at the tree, because that tree is non-zero in this case. It will message the global logic ID1, so we'll go and have a quick look at what that does. Message ID1 here. It increases the number of presents that you've delivered because you've delivered it to the tree. It messages the screen to say that you've delivered another present, which will update the number of presents in the presents collected instruments, and then check to see if the number of presents delivered is equal to 6, which means you've delivered all, and if it is, then it waits for you to stop pressing any keys and jumps to the windscreen and plays a sound. So it messages global logic, sets the variable present logic to 0, present object to 0, so you're not holding a present anymore. Messages the screen again, the same message up here to say you're not holding a present, so just clears that instrument to say, telling you which present you're holding, and then plays a sound for delivering a present. And the last thing down here is if you haven't got a present, then it checks to see. So this is basically you've pushed the fire button when you haven't got a present, so you're not dropping a present anymore. It'll check to see whether you can actually collect a present, i.e. are you standing on top of a present at the moment. and that's defined by the value of the on-present variable, which you saw changing when I was standing over the teddy bear. So if you are on a present, it will message the present ID 0. We'll follow that so we can see what it does. It's a very simple one. This just basically messages, it sets the global variable got present to its present type, marks the present as invisible, so it turns it off, and clears all of its layers so that it can't be interacted with anymore, just in case, and then messages the screen with the present type to say which present you're holding, and that will update the message at the bottom of the screen saying you're holding the teddy bear or the bike or the book or whatever. So that's that. Where were we? Message screen. Lost. There we go. So that messages the screen, and where are we here? Messages the object, and then it sets the present object to the object that you're standing on, or you're standing, you're touching, so that it indicates internally that you're holding that present now. Messages the screen, which it probably doesn't need to do twice. Actually, I need to look at that because the present itself was messaging the screen, so this is probably redundant, and then just beeps a sound to say that you've collected a present. So that's all of the logic on the player, which in reality is the vast majority of the logic in the game, and we've touched on most of the logic that it impacts on as well, messaging global and other objects. So hopefully that helps to explain some of how the various bits and pieces work. You can go back and stop and pause and look at some of the flows to see if you can understand better. Next we'll move on to the screen logic and some of the other objects. So very briefly, the only other objects that have any logic on them at all are the present and the chimney. The present we've already touched on, so this is only a single message handler. It's sent by the object when it picks up a present, and the reason it's on here is that the present itself knows the present type, and it can communicate that to the global variables to say which index 0, 1, 2, 3, 4 or 5 the player is currently holding, and then just sets itself to invisible and messages the screen to say display that present. So it's fairly simple. So we can see the presents are all map level objects. The reason for that is you can pick them up from any room and drop them in any other room. If they were room level objects, you couldn't do that. They wouldn't be able to exist in other rooms. So they're all global. So if we look at the teddy bear, for example, this one in the first room, if we have a look at its variables, it's got a present type of 4, the toy car 3, football 2, and so on. And then that matches to, if we go to the rooms and pick this room here and the chimney, this index is the type of present that it needs for that chimney that house to become active. If you remember the logic that checks to see whether the got present and the needs present match. So that's basically what the present, that's where that logic's coming from. So that's all the present does, is just basically communicating various things around when it's been picked up. And then the chimney check just has 2 message handlers. The first one is triggered by the Santa. So this message handler, message 0, is triggered when Santa tries to go down a chimney but doesn't have the right present. So this will message the screen with the present that's needed. It basically sends the same index, it's just the present goes to the screen logic, and the screen logic will print the message underneath the child name, wants, and the present name. And the child name and the present names are matching. So if we look at the data, you can see we've got Avery, Robin, Devon, Jamie, Quinn, Casey, bike, doll, football, toy, car, teddy bear, storybook. They're all, so Avery wants a bike, Robin wants a doll, Devon wants a football, and so on. So they're just ordered that way. So it just needs to send that number through twice. The reason they're separated is I did used to have different potential for different indexes for the child and for the toy, but it seemed silly, so I ended up just matching them and just getting rid of one variable, save some space. And then the other message is it's sent by the object, that's by Santa, when he touches on a chimney object, a chimney check, and all it does is sets the global variable needs present to this present index, so the logic can later on check to see what's needed to get into this chimney. So that's the rest of the logic on the objects. There's no other logic on objects. If you have a look at rooms, they don't have any logic either. So that's all nice and simple. It's all kept into the it's all kept in the objects. But the screens do have some logic. So the menu, we'll start with the menu, which is the start screen. Really simple logic. It's just every frame, check to see if any key is pressed. If it is, wait for the key to be released, reset the game, and switch to default screen, which is the game screen. So that's this menu screen basically, which is just a bunch of instruments with some text. The win screen is very similar. It's just a screen with a tile map for when you win, very simple. And this just basically checks for any key, waits for the key to be released, and then switches to the menu screen to restart the game. And then you've got the default game screen. Now this is where you've got most of the screen logic. So this is what happens during main gameplay. We've got a bunch of instruments here. So we've got this instrument here, which is displaying which present is held. If you remember, I passed a bunch of messages to the screen to say the player's now holding this message, and that takes the string for that. And then we've got these three here. This is always wants a, and the child and the present will be changed depending on what the chimney check communicates to the screen when you try to go down a chimney with the wrong present. So if you have a look at the logic very simply, first of all, initialize. So at the very start it sets all of these to empty. -1 is for these text instruments, means display nothing. And then on message 0, which is when we want when basically you've tried to go down a chimney but you don't have the right present, it takes in the present index, the child index and the present index, and it just sets the wants and child, it sets that to 1, which is, it sets wants to 1, which is wants A, and then it sets the child and the present to the names of the correct present. So we had 2 and 8. So if we look at the data, 2 is the first child and 8 is the first present. So then it just adds whichever present index to get the right string, and then displays that. And then it sets this variable timer, which is just a single variable on this screen, to 50, which ostensibly should be about a second or so. And then related to that, we've got down here this always trigger, which if the timer is greater than 0, it will reduce it by 1. If it's equal to 0, it sets the 3 instruments to empty. So basically that just means when you first try to go down a chimney, it will print up Avery wants a doll, and then wait for a second, then clear them, so they don't just sit there forever. They just sort of, they're temporary messages. So that's the messaging about the presents. And then we've got a couple more messages here. One is for when, let me try and remember, 23, I can tell by looking at the tile. Yeah, so this is when the lives change. So if you lose a life, it'll go through, it does a loop 3 until 8, which is 3, 4, 5, 6, 7. It stops at 8, so it won't do 8, step by 1. So it's going through those instruments, and it's setting the tile, because they're tile type instruments, if we have a look, they're tile type instruments, to either -1, which is empty, or 23, depending on how many lives you've got left. And 23 is the Santa's hat. So if the number of lives you've got left is greater than or equal to this instrument, it will print the hat. Otherwise it'll wipe the hat out, so you've lost a life. And then we've got the same thing here. This is exactly the same. So this is when a present is delivered. It does exactly the same thing, going through 9 through 15, which is these ones here, the gifts, and it sets it either to -1 if you're holding it, if you're holding that number of presents, or 36, which is the present icon, present tile. So that's just basically filling in these depending on how many presents you've got or how many lives you've got. And then finally we've got message 2, which is when a present is collected. So that basically takes in the present index, and if it's less than 0, it'll set the present held to -1, instrument to -1, which clears the present held, so you're not holding any present. Otherwise it'll add 8 to it, which is the start of the present names in the data, and sets the present held value to that. So we can see this in operation here. If I just quickly go up to here and hit fire, then you can see it's now collected the teddy bear and puts that message on the screen. So that's all the logic on the screen, and that's all the logic on all the screens. We've got some game logic, some of which we've already touched on. So initialize at the very start of the game just basically sets all of the relevant variables to 0. So you've got 5 lives, you haven't delivered any presents. It messages the screen to say that the number of lives and the number of presents collected have changed, so that will clear out all of those, or reset all of those instruments, and then sets the got present to -1, because you're not holding anything. The messages we've already covered what they do. So if you get this is presents delivered for and the win, and this is killed and respawn timer, and we've covered the respawn there. So I think that pretty much covers everything. If we have a quick look at the sprites, I don't think there's much to cover here. These are fairly simple 16 by 16s. I originally did them as 24 by 24s, which was a lot easier to fit these sort of images in, but decided to run out of space, so switched down to 16 by 16, and they're not masked because they always sit at the back. The baddie is, for anyone who's seen the other video I was working on with the Attic Attack style game, is stolen from there because I ran out of time to design a baddie. In terms of the rooms, they're fairly simple. There's a lot of brushes, so if we go to room 1, I've tried to use brushes as much as I can to try and reduce overhead. So if we turn off the brushes, you see a lot of things disappear. There's a few extra bits and pieces to customize. Just these bits are put on to make each one a little bit different. The baddie is animated, so if we play that, that's the animation that the baddie goes through. And we've got a chimney and a couple of markers, so that's respawn marker and the return from interior marker. And the same thing applies to all of these, so they're all largely done with brushes where possible. If you turn the brushes off, so this has got some extra stuff in it. Even the interior is largely done with brushes as well, where appropriate. The ladder is a brush, and these also have animated baddies. So again, if we play, you can see that one moves If I zoom out, you can see he moves. I just wanted to touch on one more element of the game and how it worked, and that's the presents themselves, because there's another trick or technique there that might be useful. So you'll notice, while there are, if we look at the sprites for the presents, 6 different presents, you'll notice there's only one object, and this is handled by and the reason for this is the logic itself only cares about a present and a particular ID. It doesn't need to have separate objects for each one, and in fact making an object for the doll, for the bike, for the teddy bear would have made the rest of the logic much more complex, because you'd have had to check on things like on hit whether the type was teddy bear or bike or and so on, and that complicates the logic dramatically. So the technique I've used is to have a single object, and if we look at the animation, I've just set up one animation with a single frame in each for each visual representation, each sprite. And then if we look at the map where they're placed, so if we pick the teddy bear for example, as well as setting the present type variable, which is used as explained before elsewhere in the logic for determining which present goes to which house, I've set an initial animation here, and it lists all the different animations that this object has. So I can change, you can just drop a present, any present, which is currently shown as a bike here. So I could drop another one. If I show you, I'd drop another one on there, and then change that initial animation to 3, and it changes to a car. So it's exactly the same object, it just looks different in each use case, but keeps the logic much simpler. The logic only cares about presents at one level, and then at the other level the index, which you can set on the variable for that object there, here. So you can determine the type it is that way. So that's how I've done that, and that means things are kept a lot simpler. The amount of export of code is reduced, because you don't have to have duplicate logic on each present. Does have some logic, not a lot, but you'd have to duplicate this logic for each present type if you had them. And as I say, if we look at Santa, where it detects, so over here, if it's of type present, we'd have to have a much more complex logic here for checking if it's of type present, or if it's of type if it's of type bike, or if it's of type doll or teddy bear, and so on, and then set the variable. So it just keeps things a lot simpler by using that technique. So I hope that's given you some insight into how the game was made. It was put together very quickly. I think in total maybe 8 to 10 hours of actual work over 2 calendar days, so it was thrown together fairly quickly, and I'm sure there are some things in there that could be done much better in the logic. Some of the things I've noticed as I've been putting this video together is there's a lot of message passing around. That's necessary to some degree to overcome the change that was made recently to remove access to other object variables from within a different object. So passing a message is the only way to actually get it to do something. I might look into things that might make that a little bit cleaner and clearer. The Santa logic in particular is quite overwhelming in terms of the amount of logic in there, so I've got some ideas to hopefully improve at least the editing capabilities, or the editing paradigm for logic in those complex situations. One idea is to allow you to filter which flows are shown, so it's list maybe in a separate area of the interface, list all the flows on this particular object and just say show just this one and this one, so you can just focus in on one particular flow without having a massive canvas of hundreds of nodes. It will make things faster and a little bit less cluttered. And I've got a few other ideas that I've been throwing around on the Discord for improving the way that data flows around in the logic graph, where you have lots of wires that cross over one another, and it becomes a little bit difficult sometimes to follow, to either follow those flows through the nodes, but also to work out where data is coming from, and trying to lay out the graph so that you don't get any overlapping wires is virtually impossible. So I've got some ideas that I might be implementing in an upcoming version to try and make that a little bit better. If there's any questions you've got about the way that it was implemented, if anything's not clear, this is a very, very quick, although it doesn't feel quick, but it is a very quick overview of how it works. It's intentionally not a tutorial or a lesson in how to build something in Kwyll, just an example of how I built something very quickly. If you've got any questions, do pop over to the Discord, and I'll be more than happy to answer them if I can over there. The content that you've seen me working on here, that was actually released as the game on itch, is available now to patrons and Coffee subscribers, and it will be available broadly to everybody at some point in the new year. I just like to give the patron subscribers early access for a little while, so I will be making this content available as an example of how to put together a simple game, and hopefully you can learn some lessons from it and take some of the techniques into your own games. So as always, if you like what you see, don't forget to like and subscribe, pop over to Discord, say hi, and see you next time.